Hello children. In this video, we are going to continue with the chapter Number System. In the previous videos, we had seen what are rational numbers. Yes, what were the rational numbers? Rational numbers were nothing but the numbers which can be written as P by Q form. Yes, where your P and Q are integers and Q is not equal to 0. Then we had seen what are irrational numbers. What were irrational numbers? The numbers which cannot be written in P by Q form, or what we can say is the numbers which are not rational, are called as irrational numbers. And both rational and irrational all together form a set that is called as a real number set. Okay? Then between any two rational numbers, there are infinitely many rational numbers. Similarly, between any two irrational numbers, there are infinitely many irrational numbers. Okay? Also, we had seen every real number is represented by a unique point on the number line, and every point on the number line represents a unique real number. Okay, this is what in the previous videos we had seen. Now in this video we are going to see the real numbers and their decimal expansions. So the question is, find the decimal expansions of the following numbers. First is 10 by 3, 7 by 8 and 1 by 7. This 10 by 3, 7 by 8 and 1 by 7, are they rational or irrational? Yes, they are rational, since they are of what form? P by Q form, where Q is not equal to 0 and P and Q are integers. Okay? So, first I am going to take the number 10 by 3. Okay? So, what you should do is, your usual division method, long division method, you have to divide 10 by 3. So, see how I will get it. It will be, I am writing here 10. This is divided by 3. So, I will be getting as what? 3 3s are 9. Remainder is 1. Right? 1 is less than 3. No number is there. So, I have to write their decimal. I will be writing here 0. Again, 3 3s are 9. Again, the remainder is what? The same. Here, the remainder was also 1. I am writing again here 10. 3. 3s are 9. So whether will it continue? Yes, the remainder I will get as 1 itself. See how will I get is in this manner. Okay, I will be getting everywhere. Here is 1 remainder. This is the 1 remainder. Again 1. Here also I have got 1 as a remainder. That means it will go on continuing. I will be getting the answer as something 3.3333333 and so on. It will go on continue. It will not stop or it will not terminate. Okay, I am getting the same remainders in this case. Now see the second question. It is 7 by 8. That means divide 7 by 8. So what will be my first should I write? What should I write the first? Since 7 is less than 8, I have to start with 0. Okay, 0 point. So I'll be writing here 70. 8, what it should be? 8 8s are 64. So here I'll be getting it as the remainder, it will be 6. Yes, again 60. 7s are 56. Remainder 4. 40. 5s are 40. And the remainder will be 0. That means I have to stop here. So whether in this case, did I get my remainder as 0? Yes. Okay. I have got first the remainder 6, then I got the remainder 4, and at the last I got the remainder 0. And I got the answer as 0.875. No number after 5. Okay, that means it is what? The decimal expansion is stopped, or I can say it is terminated. Okay. See the next question. It is 1 by 7. 1 by 7, again divide 1 by 7. So again it is 0 point, since it is less than 7. I'll be taking here 10. So it will become what? 7 ones are 7. Remainder is 3. Again I'll be writing here 0. 4s are 28. Yes, remainder is 2. 20. Then it becomes what? 2s are 14. Remainder is what? 6. Check whether the remainders are repeating. First, here the number was 1. Then the number is 3. Remainder is 2. Now 6. I'll be writing here 0. 8s are 56. Remainder is 4. So again 40. I'll be writing it as what? 5s are, I'm writing it here, 35. So remainder is 5. Again 0. Then 7, what it is? 7 sevens are 49. Remainder is 1. I'll be writing here again 0. It will be what? 7 ones are 7. So will it continue again the same? See, I had first it was 1. Okay, then I wrote it as 0 and I got this as the decimal. So if I continue, I'll get the same set of digits again. Okay, so I'll be getting it as like this. It was 1. Okay, then 7. 7 ones are 7 and so on. I got my remainders as 3, 2, 6, 4, 5, 1. Again if I go on, it will be repeating the same because here I have got that 1. Okay. So in this, what have I got? I have got whether the decimal expansion is terminating. No, it is going on, means it is going on what? It is non-terminating, and that too it is repeating, I can say. Repeating. Yes, is it repeating? Because if I go on, I'll be getting again 1, 4, 2, 8, 5, 7 again 1, 4, 2, 8, 5, 7 again. That means same block goes on repeating. Okay. Now suppose if I have it as 1 by 6. 1 by 6, that means what I'll get here? 1 divided by 6. So it is 0 point. Again it will be 10. 6 how many is are? 6 ones are 6. Remainder is what? 4. 40. Okay. So again it will be 6. 6 are 36. Remainder is what? 4. 40. Okay. Again I'll be writing it as 6 remain 36. So will it be continued? See whether my remainder I'll be getting the same. Okay, that means this 6 will be continued. So what will I get is, I'll be getting it as, it is 1 by 6 I'll get as 0.1666 and so on. That means my 6 digit is repeating, and it is what? Non-terminating. The decimal expansion, it is non-terminating and it is repeating. Okay. So in this 3 examples, we had seen that either your remainder it becomes 0 or the remainder is not 0. So if the remainder becomes 0, such decimal expansion, we can say that they are terminating decimal expansions. Okay. Suppose if I have 1 by 2. What is the answer of 1 by 2? It is 0.5. Yes. Because when I divide 1 by 2, I'll get it as 0.5. So in this case, I will have it as terminating decimal expansion, since I will get here remainder as 0. Okay. Now see, the next case is the remainder never becomes 0. which we had seen in the previous examples. Okay, so such decimal expansions are called non-terminating recurring, or you can say it as a repeating decimal expansion. Non-terminating, it goes on, and recurring, that means it is repeating. Yes, 1 point, suppose it is 6 6 6 6 and so on, that means it is recurring and it is non-terminating. Okay, now see here, 10 by 3, we got it as 3.333 and so on. Now after the decimal point, check whether this 3 is repeating. So that repeating number, I can write it as 3.3 bar. That block of numbers which repeats, that should be, no need to write it as 3333. We can write simply as 3 and over it you should give a bar. Okay. Similarly, now here I have got 1 by 7 as 0.142857, again 142857. Whether this block of numbers is repeated. Yes, so what should I do is just that block of numbers I have to write, and over it I have to give a bar. Okay, so it represents what? When I mark it as, suppose the number I have written 1.2 bar, that means it states what? It is nothing but 1.2222 and so on. That means such type of numbers are what? Non-terminating repeating or non-terminating recurring. Okay, now see the next one. I have here 1.3272727 and so on. Now whether in this case my 272727 is repeating. So how can I write it as 1.327, its bar. That means this block is repeated. Okay, clear? Same for 60.515151, which block is repeated? 51 block is repeated. So it has been written like this. Hope this is clear. Okay. So they are nothing but what? Rational numbers itself. Now see. So how we can define a rational number in decimal form? We had a definition if it is of P by Q form. Now we will see the definition of rational numbers in decimal form. A number whose decimal expansion is terminating or non-terminating recurring is called rational number. That means if I have 0.15, that means this decimal expansion is what? It is terminating. It is stopped. So it is a rational number. Then again, it should be either this or non-terminating recurring. That means if I write it as 1.27 bar, is it a rational number? Yes, because I can write this as 1.2777 and so on. It is non-terminating and recurring. It is repeating. 7 number is repeating there. So it is nothing but a rational number itself. Now we'll see what is an irrational. Previously what we had said, if it is not a rational, that means if it is not of the form P by Q, it is irrational. So what we had seen for rational numbers, it should be terminating. So for irrational number, it should be opposite. So it should be what? A number whose decimal expansion is non-terminating. Here it was a recurring. It should be non-recurring. No recurrence should be there. Then I can say it will be an irrational number. So non-terminating and non-recurring. Okay. Now see, this number I have 0.12, 12, 012, 0 0 1 2 0 0 0. Now you may say that here 12 12 12 are repeating, but whether is it like this 12 12 12 and 12? No, it is not the same. How it is? Here 12, here 12, then 0 1 2, again 0 0 1 2 0 0. Same block is not repeated. Okay, so this number is an irrational number. Okay, is irrational. If I write it as 0.121212, it will be an rational number. Okay, hope this is clear. I'll see some questions regarding it. Write the following in decimal form and say what kind of decimal expansion it is. Okay, now 21 by 100. It is a rational number. What we had seen for rational, either it is what? Terminating, or it is non-terminating repeating, or non-terminating recurring. So here 21 by 100. Since it is 100 multiple of 10, directly can I write the decimal expansion? No need to divide it. So I can write the same as 0.21. Since 2 zeros, I have to move 2 steps to the left. So I'll get as 0.21. So how is the decimal expansion here? It is terminating. So what we can write it as, the decimal expansion is terminating. Okay. Next one. 2 1 by 3. Now 2 1 by 3, it is a mixed fraction. So first convert that fraction into your usual fraction, that is improper fraction. How to do? I have to do it as 2 into 3 is 6. 2 into 3 is 6 plus 1. So will I get it as 7 by 3. Okay. So I can write it as 7 by 3. Now divide 7 by 3. It is what? 3 2s are 6. Remainder is 1. 1 is less than, so put here decimal point 0. 3 3s are 9. Remainder is 1. Again if I put here 0, I'll get 3 3s are 9. Again my remainder will be the same. That means again what is it? My remainder is what? Recurring, repeating. And this decimal expansion is non-terminating. So I'll get here this as, it will be my 2.333 and so on. Since 3 is repeating, may I write it as 2.3 bar? Yes. So this expansion is non-terminating and repeating, or non-terminating recurring. Okay, this is what we have got. Next is, classify the following numbers as rational numbers or irrational numbers. Okay, now you have two definitions for rational and two definitions for irrational numbers. So according to that you have to check. So first is square root of 15. Is 15 a perfect square? No. I cannot tell what is square root of 15 as it is not a perfect square, right? Because 3 3s are 9, then it is 4 4s are 16. I don't have any integer whose square is 15. So I can say that it is an irrational number. Now next is square root of 49. Don't write, since it is square root, directly it is irrational. 49 is what? A perfect square. 7 into 7 is 49. So I can write root 49 as 7. But 7 is what? It is a rational number. Okay. Now next, 0.5656 and so on. Which form is it? 0.5656 and so on. Here is my 56 repeating? Yes. Is it non-terminating? Yes. So I can write it as 0.56 bar. So is this my non-terminating repeating? So it will be what? It will be a rational number. Okay. See the next is 5.110, 1110, 11110 and so on. Yes? Any block is repeated? No, here 110. When it is triple 10, when it is 410. So no block is repeated. It is non-terminating and non-repeating, and hence it is what? Irrational number. Okay? So in this video we are going to stop here. Hope this is clear. We have seen the decimal expansions of rational numbers and decimal expansions of your irrational numbers, how it will be. Okay?